If you take a closer look at the routing process, you'll find that a router actually begins by receiving a frame. It receives the frame on the input interface buffer. This is actually the holding area where packets are going to wait to be serviced by the router as they're being received off the wire itself. If the input interface buffer fills up, this means that the router does not have enough capacity to be able to process all the packets. In this case, the packets will eventually be dropped. This is called a tail drop in a buffer queue. As these packets arrive on the input buffer, the router will de-encapsulate the frame one by one and will notice that they're IP packets. It will then take the first IP packet and check to verify if the packet will stay with the router itself or if it will be sent to a local router interface or a next hop router. If the packet needs to be forwarded to the next hop router, the receiving router will consult the routing table to figure out how to get it there. Let's assume that this network packet comes in with a destination address and is to be routed to 192.168.3. The only way for the receiving router to move data to the 192.168.3 network is by moving it via the 10.1.1.3 router. So there should be another router that this particular router is connected to on the same subnet, which will allow it to get to the destination network. The receiving router does not really care how many routers the packet must go through. It only needs to point to the next hop, something that you do not see in this example of the routing table that's being shown here. Is at the end of the next hop address, it will also show the output interface. The output interface is identified so that the router knows how to get out to 10.1.1.3. It might be via Fast Ethernet 0 or Fast Ethernet 1. We can't really figure this out because it's not depicted in the example here. Regardless of this, the output interface buffer is very important because the router has to determine whether or not it has the MAC address of the destination. If the router has identified that the packet is going to stay with it, the router will use ARP directly. If the packet needs to be forwarded, the router is going to use the MAC address of the next hop router and will forward it. Outgoing interfaces will encapsulate the packet for the correct media, and then it will forward it based upon whether it's identified in this routing table. So the routing table serves a very important role in the functioning of any router.